This is number 4 in section 4.6, and here we're going to determine the general solution. Now, I've done the first part in this problem where I found the homogeneous part of the solution. You can see it here by finding the companion equation, and then m was plus or minus I. So now let's get on to finding yp, the particular solution to the problem, using the method in section 4.6. So we know we need 3 determinants, so let's start there. We'll find the determinant of the matrix A, and that's where we take our 2 functions, say cosine theta and sine theta, and then we take the derivatives, and here we get minus sine theta, and here we get cosine theta. And take the determinant where we go first this way, so cosine squared theta minus, and then this way. And we have minus sine squared theta, so that becomes a plus here. And that's exactly 1. And the next matrix is going to be A1. And for that, I'm going to substitute into the first column 0, and then secant theta, tangent theta. That is exactly the function that was right here to the right, at the right-hand side. And then the other side is the same as the matrix A, so sine theta, cosine theta. So I get 0 times cosine theta minus sine theta times secant theta, tangent theta. Now this is exactly, let's see, so this is minus sine theta, secant is 1 over cosine theta, and tangent is sine over cosine. So this is minus sine squared theta over cosine squared theta. Or that's exactly minus tangent squared theta. Okay, and then now A2, we substitute instead, so we keep the same, the first column the same from the matrix A, and then the second column becomes 0, secant theta, tangent theta. And in this case I have cosine theta times secant theta, tangent theta. And that becomes, now secant is 1 over cosine, so these two cancel and I get tangent theta. Now there's one thing that I did not address just yet, but you see we have tangent theta, so we have cosine theta in the denominator, so we have to make sure that that's never 0. So we're speaking here for theta between minus pi over 2 and pi over 2, so that cosine is not 0, and then everything we're doing is defined. So now I get that u1 prime is exactly a1 over a, and a1 is tangent minus tangent squared theta. A is 1. u2 prime is tangent theta over 1. Okay, and so now we have to find u1 and u2, and so u1 is the integral of minus tangent squared theta d theta. And let's go ahead and work this one out. Using a trig identity, this is the integral of 1 minus secant squared theta d theta, which is theta minus tangent theta. u2 is the integral of tangent theta, which I'm going to write as sine theta over cosine theta d theta. Then if u is cosine theta, then du is minus sine theta, so I can use u substitution to get that this is minus the ln of the absolute value of cosine theta. But between minus pi over 2 and pi over 2, cosine theta is positive, so it's minus the ln of cosine theta. And I'm running out of time here. I don't want to make these too big, so I'll continue in another video.